Now, let's do a general review on why is microplastic being added to products. Here are the categories or products on the right side in which microplastics have a specific function or purpose. The most famous or the most common role of microplastic components is the abrasive effect or peeling. We speak of abrasiveness or abrasive material when the material, due to its hardness, is used to grind a softer material. This can be the skin itself, for example. Microplastics are also used as an emulsifier to enable the mixing of chemically diverse liquids or substances that do not otherwise mix. It may also have a binding function or a filler role. In pharmaceutical solutions, it enables the controlled release of ingredients when we talk about capsules, allowing a more controlled or gradual release of an active substance. The formation of a protective film, the function of the surface coating is also possible. Then, microplastics can improve the chemical and mechanical resistance of a product. Finally, they can act as an absorbent of liquids, such as in various hygiene products we use in everyday life. Then, microplastics can act as a thickener, mainly in paints and cosmetics. They also have an aesthetic purpose of improving products' visual properties. It can also work as a flocculant, for example, in the case of wastewater treatment. If you may not know this word, flocculant is used to eliminate turbidity in larger pool waters and sewage treatment plants. It scorches smaller microparticles into larger ones to be more easily removed from the water during mechanical cleaning and other procedures. Then there is the function of drainage, dispersion, and the role of a turbidity agent, which is related to visual effects and an anti-static agent's role. So we see that the functions of these microplastic components that we find can be very diverse. Of course, using them also increases the emissions into the environment since the emission channels are very diverse. I listed everything here with the intention that you look at it later, but we will not go into details now, maybe only the first three. We often have these types of products at home. So personal care products and cosmetics. Many studies and literature divide products into rinse-off and leave-on products. Rinse-off are those products that we wash off after use, while leave-on are those that we apply to different parts of the body. Then there are super absorbents, and as you can see, their emission pathways are different. They can be through direct human output, solid waste when we dispose of these products, or through household wastewater, when we wash a product and the microplastics is rinsed to the drain. The same goes for detergents. As we can see, the emission routes are via wastewater or solid waste. When we talk about paints, inks, coatings, the emission routes depend on the product's use area. We are even interfering more in industrial use, as paints, coatings, and inks are widely used in industry. We also have additional emission routes into the environment, such as spills of paint during the application, transport, and abrasions. Then there are the emission routes of industrial abrasives. What are possible routes to the environment in agriculture, where soil and groundwater may also be affected? We have a pharmacy, wastewater treatment, construction, and, of course, others, such as furniture, soft toys, adhesives, and sealants. From these examples we can conclude that we, humans, are in constant contact with microplastics in terms of function, categories, and emission pathways.